Calculation 9 in Chapter 1, Heat Capacity of Real Gases. Calculate the heat capacity Cp of ethane vapor at 400 degrees Kelvin and 50 atmosphere. Also estimate the heat capacity ratio Cp over Cv at these conditions. To calculate heat capacity of ethane vapor, we can add delta Cp to the ideal gas heat capacity Cp with superscript O as given by this equation. Delta Cp will be found from a chart in figure 1.4 as we will see later. The units of this heat capacity is calorie per gram mole per degrees Kelvin. Now let's calculate the ideal heat capacity for ethane using the temperature of 400 degrees Kelvin. Cp ideal is equal to 2.247 plus 38.201 times 10 to minus 3 times 400 Kelvin minus 11.049 times 10 to minus 6 times 400 Kelvin to the power 2. Cp would be equal to 1576 calorie per gram mole per degrees Kelvin. We need to find a value for delta Cp from the chart in figure 1.4, but in order to use the chart we need reduced temperature and reduced pressure, Tr and Pr. We have the critical temperature of 305.4 Kelvin and critical pressure of 48.2 atmosphere for ethane vapor. We can calculate Tr by dividing 400 Kelvin by the critical temperature of 305.4. This will give us a Tr value of 1.31. Pr is calculated by dividing 50 atmosphere over the critical pressure of 48.2 atmosphere. This will give us 1.044 Pr. Let's use figure 1.4 in order to estimate delta Cp. We had a value of Pr equal to 1.04, which is very close to 1 here. And we had a Tr value of 1.31, which should be very close to here. And as a result, we will read a value of 3 for delta Cp. Now, having calculated the ideal heat capacity of 15.76 and finding delta Cp of 3 from chart, we can calculate the real gas heat capacity for ethane vapor as Cp equals to 3 plus 15.76 equal to 18.76 calorie per gram mole per degrees Kelvin. This is equivalent to 18.76 BTU per pound mole per degrees Fahrenheit. The heat capacity ratio is given by this equation where Cp value has already been found and the Cp minus Cv can be found from the chart in figure 1.5. Let's use the chart in figure 1.5 to find a value for Cp minus Cv. The PR value, as we found earlier, was 1.04, which is close to here. And for TR of 1.31, we should get a value of 4 for Cp minus Cv. Now, we can use Cp that we have already calculated as 18.76 and the Cp minus Cv equal to 4 that we found from the chart. So Cp over Cv would be equal to 18.76 divided by 18.76 minus 4. This will give me 1.27 as the ratio of Cp over Cv. Let's look at the Cp over Cv ratio for ideal gas. As we know, a gas like ethane will behave ideally at low pressure. However, in this problem, since the pressure is too high, like 50 atmosphere, that's why we call it real gas. But if we assume that the pressure is low and the ethane is behaving ideally, Cp minus Cv for ideal gas is equal to R, which is equal to 1.987 calorie per gram mole per degrees Kelvin. And also the Cp for ideal gas have been already calculated in the beginning of this video. We can use those values and get Cp superscript over Cv superscript for ideal gas as 15.76 divided by 15.76 minus 1.987. This will give me a ratio of 1.144. This is comparing to the ratio for real gas of 1.27. So this can tell us the effect of pressure on this ratio for ethane vapor.